Hello guys, and welcome back to another video of the Java game development tutorial. So it's currently 10:43 p.m. so I do sound a little tired, not only because it's late, but we also just moved into our new apartment, so I'm a little tired from that. So let's get right into it. Today we're going to be learning how to create a display, and we're just going to create the display. So open up IntelliJ. Now, if you don't have IntelliJ installed and um, you're using Eclipse or NetBeans instead, I highly suggest switching over to IntelliJ. I always joke about how it's the superior IDE, but in the end, it really just is a superior IDE. It's better for learning, beginners, and there are more tools to help you build your projects faster and easier, and it's also very, very straightforward compared to an Eclipse. So, hopefully you have IntelliJ installed. If not, you can always use Eclipse. However, following along might be a little different. You might need to do some research as um, maybe changing up the class path a little. I believe that's a little different on Eclipse and IntelliJ. I used to use Eclipse, but then I heard of IntelliJ, switched over, and now I love it a lot better. So, let's create a new project. And the important part to look at right now is that we're going to be using this Java. We're creating a new Java project, not a Maven or a Gradle project. Maven projects and Gradle projects are the preferred type of project. However, since this is for a beginner, beginners should not really be using Gradle and Maven. They should be learning the basics of Java, which is why we're just going to use standard Java. Now it's going to ask you for your project SDK. I'm using SDK or JDK 1.8.0 U291 or 291 version 291, but actually at the time of recording I am currently running Java version 3.01. Now, I would suggest using Java version 8 and above, so if you just go into your browser and search up JDK 8 download and go over here to the Oracle website, you can see you can download the Java development kit. I'm using 8, but anything higher than 8 is perfectly fine. Just do not use anything below 8, for example. If you just search JDK download, go over here, you can see the latest is 16, and you can always download 16. Now, hopefully you have this set up, because if you don't have this set up, then you're probably a complete beginner, and you should not be watching this tutorial. Hopefully Oracle does come out with a version for Java in Windows 11 very soon, because I will be updating to Windows 11. Sorry I keep stuttering it again. It's really late. Well, not really late, but I'm really tired. And yes, I have made a Minecraft mod. So just press next. And next, we're not going to be creating a project template. And the name, I'm just going to set it to Game Engine Tutorial. And finish. You can see it created a folder on my desktop. I'm just going to expand my window. And over here on the left, you will see the hierarchy. So, for today's video, all we're going to be doing is creating the launcher, the main class, and the display. Now, our entire game is going to be put into this one package within the source folder. Besides the assets will be in a different folder outside of the source folder. The source folder is this blue folder, if you're on IntelliJ, called SRC, which is short for source. To get started, right-click the source folder and click New, Java Class. And we're going to want to name this Launcher. Okay, so now right-click the source folder once again, click Create a New Package, And now we're going to create a package. A package is simply a folder, and you can actually see these folders in the File Explorer. So, let's create our package name. So the way I like to name my main package is by doing com dot my names, which is Lorcan, dot, and then the name of my project, which is Game Engine, and press enter. Now each dot represents a new folder, so therefore com is its own folder, Lorcan is its own folder, and Game Engine is its own folder. So if I actually look inside of my folder in Finder, you can actually see that if I go to my source folder, I have a folder named com. If I go in here, it says Lorcan, and if I go in here, it says Game Engine. So, let's take our launcher class and drag it into our package. And we're just going to press refactor. Basically, refactor means change the name of the class, and since the name includes where the actual file is, then technically we're changing the path or where the file is. And in this case, we're changing the launcher. So we have our launcher class inside of our main package. This is where we will launch our game, and it's a very, very simple class. Here we're going to store our main method. To do this, simply type public static void main string args for arguments, and then create your method. And the letters or the word main should turn gold. Now hopefully you know how main method works. If not, again, you probably should not be watching this video. You should be continuing to learn the basics. So, next we're going to create our main class. Right click, new, Java class onto our package that we made, and type in game. So, this game class is going to be the main hub for our game. So let's get started with writing our game class. I will zoom in a little so that you guys can see it better. So, first off, we are going to be starting off with creating our constructor. We can say public game, and we now need to type in the parameters. Again, if you don't know this, do not watch this tutorial. Learn the basics first. Now we're going to pass in 3 parameters. And those 3 parameters are going to be the string, which is the width, the string, which is going to be the title, and then 2 integers, which is the width and the height. So let's do that. Okay, so these are all defining characteristics of our actual display, or in other words, our application window. So then, go up here and do public final string title, public final string width, and same thing for height. Now, we will be initializing these variables inside of the constructor. That is where this final keyword comes in. Final means that you initialize it inside of the constructor. So to do this, we're going to want to say that this title variable is equal to this title variable, and so on and so forth with the other 2 variables. Now, how do I tell these 2 apart? Well, when we say the keyword this, we are referring to the class. So, we are referring to the global variables. Now, I'm not expecting the watchers to know what final means or this means. However, I do expect you to know what a global variable means. Maybe you don't know the concept by this name, though. By global variable, I just simply mean a variable on the class side and not a local variable which is inside the method. So these 3 variables are global because they are in the class and not inside of a constructor nor a method, and a local variable would be in here. this is an example of a local variable on line 12 because it is inside of a constructor. So, to differentiate between a global variable and a local variable, we're going to want to access the global variable, so we do this dot title. And then we're going to set that equal to the title that we passed in the parameters, so we're just going to say title. And you can see our error went away. Now we will want to do the same with the width and the height. Okay, so I made a little mistake here. I put string, should have been integer. So, now we have created the dimensions, and I promise you that this video will start to speed up. And this series in general will also speed up a lot. And I know I'm talking like a robot. Okay, so now let's create the thread. The thread is what the game will be running on. Now, I would suggest watching a separate video about threads, because threads are literally parts inside of your hardware, or which is your actual computer. And in this case, we're going to be talking about threads, basically like the main platform that the game is running on. So, for example, the thread is a thing that is constantly looping. So, when you are running a game such as Minecraft, as we know, an image is a video is just a bunch of images being looped together. And in a video game, what it is a bunch of images that the computer is creating to make it simulate some sort of perspective. And that loop, or that constant, I can't explain this very well. Okay, so I'm just gonna skip it and let's just create our thread. So we're gonna create a private thread called thread. And again, if you want to learn about threads, watch a different video. I am really bad at explaining it. Then we're going to create a private boolean called running, and we're going to set that equal to false. So, now up here in our class, we're going to say that the game implements runnable. Now, it's going to give us an error because it's going to ask us to implement the method run. However, let's hold off on doing that. Next, let's create our pre-init, init, and post-init. All three of these will be methods. These are simply the methods that are called upon initialization, and they are exactly what they sound like. The pre-init will be called as a pre-initialization sequence. The initialization sequence will be called after the pre-initialization sequence, and then we're going to have a post-initialization, which is just called post-init. Next, let's create our run method. So we can go up here, simply hover our mouse over it, or do Alt-Shift-Enter and press Implement Method. Then press OK. You can see that it creates a method that says public void run, and it has this @override tag on it, simply meaning that it is part of this runnable. Okay, so now we have to actually create what you would see in games, the calculator, that basically makes sure that the game is running at a constant FPS. FPS, if you don't play many video games, means frames per second, but in this case we're going to be making it, the calculator is going to determine the FPS and the TPS. In this case, TPS, how I refer to it, is ticks per second. That's how many times per second the game updates. Now, for the sake of this video, we are going to be doing it every 30 frames. Actually, you know what? Every 60 frames. So, let's first in our run method called the pre-init, then the initialization, and the post-init. So these are all going to be called once. Next, we're going to create a couple of variables, and I will just create them and then explain them after. Okay, so we've created all of our variables. The first variable is an integer called the FPS. Here we're basically stating how much FPS the application will be running at all times, or at least how much it will try to run. Now in the double time per tick, I'm just going to count how many zeros there are for you. So we have a 1, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 zeros in here. So let's just do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now to get rid of this error, we just want to state that it's a float, so put F right there at the end. Then we're going to just say delta time, and the rest of the stuff isn't as important. And I don't understand it fully myself. However, this is a very standard way of creating a thread, or just regulating a thread in a game engine in Java. Then we have the time per tick, the delta. Now, you don't really have to understand this, because I don't either. So, let's create a while loop. Actually, no, I do understand it, but it gets kind of complicated. Let's create a while loop. Type in running. So while the game is running, and remember, running is a variable we created up here on line 11. So while the game is running, we're going to set now to system.nano time. And again, I'm just going to write the code. Okay, so I've written all the code. Whoops, I forgot one. Let's just call it stop here. Actually, sorry, no. So I've created the code. However, I believe I missed something. Sorry, I believe I missed one line. I did ticks plus plus, ticks equals, oh, okay, never mind. Okay, so I've created this, and first let's make sure we have this number correct. So I'm going to count out how many zeros there are. So we have a 1, and then we have a, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we are setting ticks to 0 along with our timer to 0, and of course we're going to set now to the system nano time. And this stuff you don't need to understand, except you should know what plus equals means. It's basically adding value. And you should also know the simple operators, and you should know that plus plus and minus minus is incrementing and decrementing. And if you don't, you can continue the series and just Google that stuff on your own. But I highly suggest that if you don't understand basics like that, just don't watch the series. Focus on the beginner stuff first. So now we're going to create the start and stop method. So we're going to do public synchronized void start. Now, you don't need to know what synchronized means, simply because that's a little more complicated. It gets deeper into threading and multi-threading. But for now, just create these two methods, and in the start method do if running, then we're going to return. So basically, if the game's already started, then there's no need to run anything but inside the start method. So then we can say running equals to true, and thread equals to new thread, targeting this, and then we're going to start that thread. Now the only thing I want you to really focus on are these 3 lines, and trying to translate that into English. So we call this start method whenever we want to start the game. However, this if statement makes sure, okay, well, if we've already started the game, then we're just going to return. We're not going to start the game again. Otherwise, if we haven't started the game and running is equal to false, then we're not going to return, and instead we're going to set running equal to true, and then we're going to create a new thread and start it. So then the stop method, if we are not running, then we are going to return, same concept as the if running, return on the start method on line 75. And then we're going to say running equals to false, same thing as line 76. And then we're going to do something a little bit different. Try thread.join catch interrupted exception e.print stack trace. You don't have to understand this, just make sure you understand what this means. Okay, so we've created all of the important stuff. Now it's time to create the tick and render method. So right above the run method and below the post init, do private void tick and private void render. Now, how does this work? Well, let's open up paint.net. The tick method, so let's pretend we have this circle and we want to move it to the right. So the tick method, so this position, or this circle currently has a position of 0, 0, 0, right? And we want to move it to the right. Therefore, we are increasing its x value, which is this first 0. So let's say we wanted it to move 1 pixel over to the right, then we would change it to 1, 0. Right? So how does this tick how do we do this? So in our game, we're going to first tick it. So that means we're going to change this actual 0 to 1. So we're going to first update the position to 1, 0, because previously it was at 0, 0. But nothing actually changes on the screen. So after we've updated the position, then we pass that information over to the rendering, and that's where we actually render that change to the screen. Hopefully you understand that. So change the position and then show those changes on the screen. So translating that into code, changing the position first would be done in the tick method, and then showing that change in position on the screen would be the render method. Okay, so that's all for the tick and render method. We don't have to focus on that today. Actually, we do need to focus on the render method. My bad. So here in the tick method, or not in the tick method, sorry, in the run method, we're going to want to do a couple of things. First of all, in this first if statement, we're going to say tick, we're just going to call tick and render. Remember, we're ticking first, updating the position first, and then after that, we're rendering those changes to the screen. Then, below here, in the second if statement, we're simply going to create a space. Okay, let's work on the render method. Over here, we're going to say buffered, actually no, let's create the display first, sorry. So go over to your hierarchy, that's this panel on the left, and look at your package. Right click it and create a new package called display. No capitalization. Next, we're going to create a new Java class inside of that display class, or display method, called display with a capital D. Hopefully you can see that. So make sure your hierarchy matches mine. So inside this display class, we're going to have a couple of things. First and foremost is going to be the constructor. So we're just going to say public display. We're going to pass in the title, the width, and the height, just like we did in the game class. And now we're going to have a private JFrame. Call this frame. Private canvas. Call this canvas. And then private final string called title. And let's import this. And then we're going to have a private final dimension object called size. So, before we get into the string and the title and the size, let's first talk about the JFrame and the canvas. So the JFrame is going to be the actual window, meanwhile the canvas is going to be on top of that window. So pretend you have a stand, that would be your JFrame, and on that stand goes your painting canvas, or basically your sheet of paper, and you draw on the sheet of paper, but that sheet of paper is ultimately on that frame, or on that stand. So, in the constructor, we're going to say this dot title equals to title, just like we did before. However, this dimensions object is just going to hold two values. That's going to be the width and the height, so we just do this dot size equals to a new dimension object, and we're just going to pass in the width and the height. Hopefully you know how an object works. Basically, we say, alright, we're creating an object and we're naming it something, and then we're going to state what we're setting it equal to. By that I mean, are we setting it equal to a current version of this type of object, or are we setting it to a new object? You can think of it as a ball. If we open it up in paint.net, or any object such as a ball, let's just say this is a ball, and we're saying that over here in this house, let's just create two different houses, right? Two different houses, and each house wants to talk. There are two people in the houses, and one person in each house, and they want to talk about they want to talk about balls. Now that sounds really weird. I mean the object ball. Okay. You know, like part of sports. So, let's say house number 1, and then this is house number 2. So, let's say house number 1 has a soccer ball, right? Let's just put the ball here. And then house number 2 wants to talk about that ball. So, you can think of house number 1, you create the ball and everything. But then house number 2, you say, alright, we're going to reference it. We're creating a new variable called ball, right? And then when we reference, and then we want to set that ball equal to the ball of house number 1. So essentially we're saying, okay, we're talking up where I'm thinking of a object. However, this object is going to be the ball in house number 1. However, if we just do new object, then we're creating a brand new ball. Hopefully that made sense. Probably didn't. I'm very bad at explaining objects, but hopefully you got that. I tried explaining that to the best of my abilities. So, let's create a private void create display, and then down here we're just going to say create display, call create display. So therefore we're creating the display the moment we create the display object. Okay, so inside of the create display we're just going to say frame equals to new jframe, setting the title to the title we passed in, and then we're going to set the size, the default close operation, etc. So let's just write that code. Okay, so here we're just saying we're creating a new frame. So we have declared that we're going to have some sort of frame, and then here we're just saying it's just that frame is going to be a brand new frame, and then we pass in the title so that it puts the title of the frame inside of this part. So then we're going to set the size, and we just pass in the size that we created. Then we're going to set the default close operation. This just determines what happens when we close out of the window. And then we set the resizable to false. You can set this to true. This just determines whether you can resize the window. By that I mean like resizing like this, resizing the window of the actual application. I like setting that to false. And then set location relative to. Just make sure that your window pops up in the middle of your screen. And then we set visible to true, because if we don't put this here, then we can't actually see the window we created. Okay, now let's create the canvas. Okay, so now we have set the canvas equal to a new canvas. We set the preferred size to the size of our JFrame, and then we set focusable to false. Now what does that mean? Well, that means whenever we click on our window, we are not clicking on the actual canvas, instead we're clicking on the JFrame. Then we simply add this canvas to the frame and then pack it all together. Now we're going to create some getters. So we're going to say public canvas, get canvas, and we're just going to return our canvas. And we're going to say public JFrame, call it get frame. And we're going to return our frame. Now if you don't know what these are getters. Hopefully you do know this though. And getters are simply a way of getting private objects or variables. In this case we're getting the canvas, in this case we're getting the JFrame, and we're doing so by calling this. It's acting like a variable or an object, and when we call this, it's simply going to return the object that we specified it to return. So in the getFrame instance, we're going to return this frame object. Okay, so we're done with the display method. So now if we go over to the game class, we can go up to the very top, type in public display, import it, call it display, and finally we are able to finish up our display. So instead of the initialization method, we can say display equals to a new display, and we're going to pass in the title, the width, and the height, and then we're going to print out a couple of stuff, which I'll show you guys in a second. But anyways, let's test it out. Actually, no, we cannot test it out. First, we have to go to the render method and create a buffered strategy. Don't worry, I will tell you guys what this is in a moment. Okay, so hopefully these little comments I put helped, but essentially we're clearing the screen below where it says clear screen. I cannot talk right now. And then we're going to draw where it says draw here, and then we're going to end the drawing where it says end drawing, which is bs.show and g.dispose. Simply bs.show means show whatever we've rendered. Now, what is this buffered strategy? What is it? It's kind of hard to explain, but I'll do my best. So, let's first think or try to figure out what a buffer means when it comes to stuff like this. So, I'm going to use a metaphor. So, pretend you need to send over three things: a circle, a square, and a triangle over to, and you need to send all of that over to this location. Let's just call this blob Greenland. I don't know. Let's just we're sending over these three shapes to this foreign place that we don't know. Yeah, okay, sorry. I'm already failing at this. Where the hell is my cursor? Uh-oh. Sorry. Okay, so let's just call this little pool to the right a house. Horrible house, but yes, let's just call it a house. And we need to send these three shapes over to here. So, what we can do is send through, let's just say the UPS. We can send that first. And then the next day, we send over the square. And the day after we send over the square, we send over the triangle. Right? Easy. All three things are going over to the destination, and all of them are being sent separately. What the buffer strategy does is they put all of these three shapes into one single box, right? So let's just create a box, just pretend that's a box. So instead of sending the circle and then the square and then the triangle, we just put, what the buffer strategy does is it puts the circle, the square, and the triangle into a box, and then all we have to do is send the box. That's it. It just saves trips, basically. It's like packaging a bunch of information together. Instead of sending a bunch of things separately, just put the information together into one box and then send over that one box over. making it easier on the computer. Here, where it says if bs equals to null, essentially we're saying if the buffer strategy is equal to null, that means we haven't actually set it to anything, in which case we're just going to create a buffered strategy. Number of buffers is exactly what I was talking about. It's basically like how many things are going to go into that package. And then the rest is pretty well explained here. We clear the screen, we end the drawing, that's it. Oh, and we draw. We're not going to draw anything today, but all we have to do right now is create the actual display. We have to actually run the game. We've created the display here. Now we just have to run the game. So in the launcher, in our main method, we're going to create a new game object. Game. New game object, set that equal to game, or call that game, set it to a new game object, and pass in the title. We'll just say game engine, and then we can say the width is gonna be the size of the display, 1200 by let's say 700. And then we're gonna do game.start. Now remember, the start method is a method we created over here. Right? So now if we just right click here, the launcher, and do run main, you can see it runs it. And we've created our display. Now that was a lot of work just for creating a window, but don't worry, this comes in handy later on when we actually have to draw stuff, because right here, even though all we did was create a display, in the end what we did was create much more than that. We created the entire system for drawing simple things to a screen directly. But that's it for this tutorial. This has been a long one. Have a good day.